Hello student, today we will learn chapter number 13, motion and time. In this chapter we learn about the motion and time. Yeah, what is motion and what is time? Okay, so the movement of an object is called motion. What? The movement of an object is called motion and the movement in which things occur is called time. Okay, an object is said to be in motion when its position changes with time. Clear? There are four important types of motions: rectilinear motion, circular motion, rotational motion and periodic motion. Yes, these are the four motions: rectilinear, circular and rotational and periodic motions. Okay, so rectilinear motion means motion in a straight line is called a rectilinear motion, and a round path having the shape of a circle is called circular path. When an object moves along a circular path, it is called a circular motion, and when an object turns about a fixed axis, it is called a rotational motion, and the motion which repeats itself after regular intervals of time is called a periodic motion. Clear students? Yeah guys, in simple words, the distance covered by an object in a fixed interval of time help you know whether the object is moving fast or slow. So, the object that shows fast motion is said to have a higher speed, while the one with slow motion is said to have a slow speed. Yes, example, a person's motions, a car motions and bicycles motions, trains motions. So, a person moves slower than cycle and a car moves slow than trains. Okay? Speed of an object is the distance traveled by it in unit time. Okay, the speed of an object can be calculated by dividing the distance traveled by the object. Okay, by the time taken to travel this distance. Okay. In other words, we can say that the speed of an object is the distance the object moves per unit of time. Speed may be written as an equation: speed is equal to distance upon time. Okay, suppose a car travel distance of 100 km in 4 hours, then the speed of a car is given by speed is equal to 100 km upon 4 hours. Then we divided by 4 in 100. Okay, so speed is 25 km per hour. Okay, so SI unit of distance including kilometers, meters and centimeters. Okay, unit of time used includes hour or seconds. Meter and odometer. An odometer or odograph is an instrument that indicates distance traveled by a vehicle such as bicycle or automobile. The device may be electronic, mechanical or a combination of two. Okay, the word derives from the Greek word hodos, path or gateway, and metrons, measure. Okay, so in countries where imperial units or US customary units are used, it is sometimes called a milometer or a colloquially and a tripometer. Okay, so an instrument on a vehicle dashboard which indicates the speed of vehicle when it is running, or it is called a speedometer. An odometer is an instrument for measuring the distance traveled by a vehicle. This is the picture of speedometer. In simple words, we can say that a speedometer instrument that indicates the speed of a vehicle, usually combined with a device known as odometer that record the distance travelled. These are the formulas of speed. Speed is equal to distance upon time. Distance is equal to speed into time, and time is equal to distance upon speed. Here is a one example. Suppose a truck travels 60 km in first hour and 80 km in second hour. What is average speed of truck? So total distance travel is equal to 60 plus 80 and is equal to total is 140 km. So total time taken is 1 hour and 1 hour means 2 hours. Okay, average speed is total distance upon time. So total distance is 140 upon time is 2 hours. Okay, so divided them. After that we find 70 km per hour is the total average speed. Clear? The next example, suppose a bus travel first 240 km, a speed of 80 km per hour. It covers next 360 km at a speed of 90 km per hour. So what is its average speed? Its average speed is the first condition. Yes, for first 240 kilometers, we know that speed is equal to distance upon time. So speed is 80 is equal to 240 is distance. So time is, we find time. So 80 into time is equal to 240. Okay. Time is 240 upon 80. So time is 3 hours. Okay. Next conditions, we know that speed distance upon time 90 into 360. 90 is equal to 360 upon time. So 90 into time and 360. So time is 360 upon 90 divided by, so we find it 4 hours. The time is 4 hours. Clear? Yes, measuring speed. So we need two things to find the speed of moving object. Distance covered means traveled by an object and the time taken to cover that distance. So we can determine the speed of an object if we can measure the distance covered by the moving object and the time taken by it cover that distance. Okay. Yes, the speed of some animals are snail 0.0018 km per hour, tortoise 0.216 km per hour, human walking 8 km per hour, okay, mouse is 11 km per hour, squirrel 19 km per hour, blue fish 46 km per hour, okay, and human sprinter, fast runner 40 km per hour, rabbit 56 km per hour, cheetahs 112 km per hour and falcon 320 km per hour. Okay, a fast flying bird is falcon. Clear? Uniform motion is movement in a straight line at a constant speed. Example, a crystalline travel on a straight path at a speed of 10 km per second. Okay, it is important to know how to figure out of uniform motion because it is the basis for the rest of physics, but uniform motion rarely exists. How many times do you see some things going at precisely the same speed in a precisely straight line? This being said, we will focus on uniform motion in grade 10, so you understand the basis. A body has a uniform motion if travels equal distance in equal interval of time, no matter how small these time intervals may be. For example, a car running at a constant speed of say 10 meter per second will cover equal distance of 10 meter every second. So, it is motion will be uniform. Non-uniform motion, a baby has a non-uniform motion, it is travel unequally distance in an equal interval of time. For example, if drop a ball from the roof of the building, we will find that it is non-uniform motion. It covers 4.9 meters in the first second, okay, and 14.7 meter in the second, and so on, okay. So, an object moving along a straight line path is said to be have uniform motion. Its speed remains constant and the motion, okay, and object moving along a straight line path is said to have non-uniform motion. Its speed keeps changing, okay. Representation on motion. A graph is a pictorial representation of the relation between two sets of a data, of which one set is of dependent variable and the other set is of independent variable. In a displacement time graph, displacement is a dependent quantity taken on the y-axis and time is taken on the x-axis, okay, as it is independently. If the position of an object changes with time, it is said to be a motion, okay. If an object has equal displacement in equal intervals of time, take a graph is a straight line inclined with the x-axis which represent uniform motion of the object. Yes, this is the picture of distance time graph. In ancient times, yes, in ancient time people used some natural event which repeated regularly after fixed time intervals to measure time. For example, it was observed that full moon occur regularly after fixed time interval and the sunrise also occurs regularly after fixed time interval. Of time in ancient time, the important time measuring devices used in ancient time were sundials, sand clock and water clock. So, we will now describe all these devices briefly. Okay, devices briefly. First is sundial. Sundial means a measured time by the position of the shadow caused by the sun. So, we know that the sun rises in the east, appear to move in the sky during the day and finally sets in the west. Due to this apparent movement of sun in the sky, the position of shadow of a vertical object and ground changes continuously through the day. Sundial has a triangular blade which is fixed vertically on a dial mark. Okay. So, as the position of sun changes in the sky, the position of shadow of blade on the dial also changes. Clear? Sand clock. Another early devices to measuring time was the sand clock. Sand clock is also known as sand glass or hourglass. So, sand clock uses the flow of sand to measure time. Sand clock, sand glass or sand glasses. This is the water clock. Water clock was yet another time measuring devices used in ancient time. A water clock used the rate at which water drips from one vessel to another to measure time interval. Water was allowed to drip from one vessel to another. Vessels kept a lower level. Okay. There are the standard units of measuring time is second. Okay, the symbol of second is S and the standard unit of time is also called basic unit of time. So, we can also say that the basic unit of time is second. Okay, and this is the normally measured in the unit of hours, minutes and seconds. Clear? So, 60 seconds means 1 minute, 60 minutes means 1 hour, 24 hour means 1 day, 7 days is 1 week, 365 days 1 year, 52 weeks 1 year and 10 year 1 decade and 100 years 1 century and thousands year is 1 millennium. Okay. Basics of measuring time, periodic motion. The principle of periodic motion is used for measuring of time. Clock and watches which are used for measuring time are based on the principle of periodic motion. A simple periodic motion. Clear? Simple pendulum. A simple pendulum consists of a small metal ball suspended by a long thread from a rigid support such that the bob is free to swing back and forth. Okay. A pendulum completes every swing or every oscillation in exactly the same time provided its length and kept constant. Clear? The two end of motion of a simple pendulum is an example of periodic motion or oscillatory motions. We will now give the definition of some important terms connected with the pendulum. These are the length of pendulum, oscillation, time period and amplitude. The length of pendulum, the length of thread from the point of suspension is center of job is called length of pendulum. Oscillation means one complete to and fro movement of a pendulum bob is called oscillation. And time period, the time taken by pendulum bob to make one complete oscillation is called time period. And amplitude, as the pendulum oscillates to and fro, the maximum displacement of the bob from its mean position on either side is called the amplitude of the pendulum. Okay. Pendulum for measuring time, pendulum clock. The periodic motion of a pendulum is utilized in pendulum clocks for measuring time. So, in a pendulum clock, the swing pendulum regulates the time. The pendulum clock were big and bulky, so they could not be carried everywhere easily. Okay, a balance wheel connected to here is spring shows periodic motions. Clear? In measurement of time, use of quartz cross. Okay, these days the regular oscillations or vibrations of a tiny quartz crystal when joined into an electronic circuit are used for measuring time very accurately. Quartz clock and quartz watches, they also called electronic clocks and watches. Very accurate measurement of time is now possible by using quartz clock and watches. The smallest time interval that can be measured with commonly available clocks and watches is 1 second. The clock and watches used in sports meets can measure time intervals that 1/10 of a second or 1/100th of a second. So, there are some clocks which can measure time intervals as small microseconds or even a non-seconds. Clear? So, students, this chapter is over. I hope you understand what is in this chapter.